is I'm going to pick up here on page 16. Not sure where we will have left off on Thursday, but I'm going to pick up here and then go through part of problem set 8. All right, so the name of this figure is a cylinder. Number of faces, there are only 2, and there's 0 lateral faces. So the only 2 faces are the 2 bases. So we have 2 bases, 0 lateral faces. The shape of the base is a circle. Okay? So the 2 faces that we have, again, are the circles that form the top and the bottom. And that has a radius of 11. For the other surface, this is essentially like taking the label off of a can. So think of like a soup can or something where you take the label off. If you were to take that label off and unroll it, it is going to be in the shape of a rectangle. Okay. And in this particular case, since the height of our cylinder is 18, that would be the height of that label. And then the length of your label is the circumference, since it's wrapping around that circle. So circumference is equal to 2 pi r, and since our radius is 11, that gives us a circumference of 22 pi, which also happens to be the length of your rectangle. Okay, the next one is a cone. Number of faces in this case is 1. There are 0 lateral faces and 1 base. Again, the shape of that base is a circle. Okay, so again, the only face we have is a circle. In this case, it has a radius of 3. One of them. And then the surface for this one is not a shape like the rectangle for a can. A cone is different, so it's going to look something like this to be able to wrap it around the cone and then come to a point. And the only dimension on there is the actual radius. Okay. All right. And then as we get into our next one, I don't know why that image isn't showing up, but we'll go through the other ones. So the height of a prism or a cylinder is the distance between the bases. So in a triangular prism like this one, you have, that's your height, and then in a cylinder, this would be your height. Okay, the height of a pyramid or a cone. So again, you can't see the pyramid for some reason on here, but you do have it in your notes packet. The height of this would be the distance of a lateral face. Sorry, wrong part. Distance from, take that back. Distance from the vertex to the center of the base. Okay, so in a cylinder, or I'm sorry, in a cone, the only one you can see on here, we have the height goes from the vertex all the way down to the center of the base. And then for these 2 figures, you also have what's called slant height, which is the height of a lateral face. And it's represented by this letter L, but we write it like that. And in a cone, there's not technically a lateral face, but it would be everything that's not the base in this case. So your L would be that height. Slant height is fairly self-explanatory. It is the height of whatever is slanted. Okay. All right. So we get to our rectangle here. How many faces does this rectangular prism have? You've got the 4 sides that go around, the top and the bottom, give you 6 faces. The name of it is a rectangular prism. And then the area of the shaded face is 135 feet squared. What are the dimensions of the shaded area? So you use the other dimensions that you have here, 15 and 12. And we know that this is going to be 15. We're just looking for our height. So the area of that particular one would be your base times your height. We know our area is 135. We know that our base is 15, and we're looking for our height. So you're going to divide by 15 on both sides, and your height is 9. So that means the dimensions of the shaded area are 9 feet by 15 feet. Okay. All right, I'm going to go through the next 2 pages, and then we're going to stop there. Okay. All right, so how many faces does this one have? You've got the 3 that go around. The top and the bottom gives you 5. What is the name of that figure? That is a triangular prism. Okay, it's a prism because it's got 2 bases, and it's triangular because that's the shape of the base. The height of the figure in this case is 24. The dimensions of the shaded area. Okay, so we know that this is 20 and this is 24. Okay, so the dimensions of our shaded area are 20 by 24. What is the area of the shaded region? That just means 20 times 24, which comes out to 480 inches squared. And then what's the area of the base? Okay, so in this case, we would want to redraw our triangle. Okay, so we've got, you want to draw it kind of as closely as you can to what it looks like so that you can get your dimensions correct. So the 20 on the bottom is your height of that triangle. In this case, we don't have this side, so that's going to be our x, but we do know that that one across is 29 based on our diagram. So here comes our Pythagorean theorem. We've got x squared plus 20 squared equals 29 squared. I'm going to speed this process up for time since we've practiced this a whole bunch. A squared should be equal to 441, which means your your dimension is 21. What is the area of the base? The base is a triangle, so our area is going to be 1/2 the base, which is 21 we just found, times the height was 20, and we end up with an area of 210 inches squared for our base. Okay, moving on to the next one. This one is a triangular prism. Again, 2 bases, and then one of the bases is a triangle, or both bases are triangles. How many faces does it have? Again, 5, 3 that go around and the 2 bases. How many bases does it have? 2. What is the height of the figure? If you remember from a couple pages ago, the height of a prism is the distance between the 2 bases. So that means that this 52 is the distance between this base and that base. So 52 centimeters is the height of our figure. The shape of the base, again, is a triangle. And what is the area of the base? So once again, we are looking for the area of the triangle. Okay, we're going to make sure we copy it as closely as we can from our diagram to make sure that everything is labeled correctly. But that means your hypotenuse is 20. If we look at this triangle on the back, that height is 10. And then we would be looking for the base of that triangle. Okay, so once again, Pythagorean theorem, we have x squared plus 10 squared equals 20 squared. Again, I'm going to speed that up and get to a squared equals 300. Square root of both parts, you get 103, and then that gives you 10 square root 3. So when we go to find the area of our base, it is 1/2 your base, which is 10 square root 3, times your height, which is 10. And we talked about you'd only multiply the numbers that are not underneath the square root. So 1/2 times 10 times 10 gives us 50 square root 3 centimeters squared. Okay. All right, I'm going to go through the 2 on the next page, and then the rest of them you guys will finish up on Monday. All right, name of this one is a hexagonal prism. How many faces does it have? There are 6 that go around, plus the 2 bases gives us 8 faces. 6 lateral faces, 2 bases. The height of the figure is the distance between the bases, which is 15. And then the shape of the base is a regular hexagon. And the area of the base, and we're going back and finding the area of our hexagon, which, if you recall, means we're creating triangles. So we've got, we divide that bottom in half by 3. Our other sides are going to be the same, so 6 and 6. And we're going to be working with our triangle that looks like this. Okay, we need to find our height. So Pythagorean theorem, x squared plus 3 squared equals 6 squared. X squared equals 37. I'm sorry, 27, not 37. And then remember that when you have these hexagons, that's when you know that one of them is always going to be divided by 3. Okay, so it's going to be 9 times 3, which gives us 3 root 3 for our height. And then the formula for the area of the hexagon is 6, because we have 6 of those triangles, times 1/2 times the base is 6, and the height is 3 square root 3. Okay, you're only multiplying the numbers in front, or outside of the root. So 6 times 1/2 times 6 times 3 gives us 54 square root 3. Okay, last one. Fewer questions on this one. The height of the figure, again, 21 millimeters. Sorry, sometimes I'm using units, sometimes I'm not. Area of the lateral face. So a lateral face is any one of these sides, which is a rectangle. And we do know the dimensions of that rectangle. So it's 21 times 16, and we get 336 millimeters squared. Area of the base, same thing we did before. Create our triangle. Our base here is 8. We know that these two sides are both 16, and we're looking for our height. So x squared plus 8 squared equals 16 squared. Cut through those next couple steps for time, and we get 192. And we know that one of these is going to be a root 3 because it's in a hexagon. 192 divided by 3 gives me 64. So that means it's going to be 8 square root 3. And then finally, the area of our base is 6, because there are 6 triangles, times 1/2 times the base is 16 times the height is 8 square root 3. Multiply all the numbers that are not underneath the square root, and we get 384 square root 3 millimeters squared. Okay, we will be finishing off the rest of those in class.